Next, test of divisibility for 7. Test of divisibility for 7. So, if the number should be divisible by 7, then how the number should be? Okay, let me take an example, 343. Let me take an example, that is 343. Okay, 343. We know 343 means 7 cube. 7 cube is 343. Definitely it is divisible by 7. So, because of that reason, I took 343. Okay, see here, whatever may be the number, you consider the unit digit. In this number, the unit digit is 3. So, I am going to multiply it by 2. In the end, I am going to get 6. See, whatever may be the number they can give, you consider the unit digit and you multiply 2 for that unit digit, you got 6. Next, what are the remaining numbers? You exclude this 3. The remaining number is 34. And you subtract this 6. You subtract this 6 from 34, you are going to end up with 28. Is 28 divisible by 7? Yes. Therefore, 343 is also divisible by 7. Okay, sometimes you won't know whether the obtained number is divisible by 7 or not. At that time, you repeat the same procedure. See here, the unit digit is 8. So, whatever may be the unit digit, you multiply 2 for that unit digit, you are going to get 16. So, next, you exclude this unit digit. You got 2. So, 2 minus 16, that is minus 14. Is minus 14 or plus 14, whatever it may be. So, the number is 14. Is 14 divisible by 7? Yes, definitely it is divisible by 7. Therefore, the number 343 is divisible by 7. Very simple. Okay, next, test of divisibility for 8. Test of divisibility for 8. So, if the number should divisible by 8, then how the number should be? See here, last 3 digits of the number should be divisible by 8, then only the given number is divisible by 8. So, let me give you an example. See here, 119,864. So, 1,19,864. So, last 3 digits are 864. So, once you divide it by 8, see 864 is divisible by 8. Definitely it is divisible by 8. 8 ones are 8, 8 8s are 64. So, 108 times. So, definitely it is divisible by 8. Therefore, the given number is divisible by 8. So, test of divisibility for 8, you have to consider the last 3 digits of the given number and you have to check whether the last 3 digits is divisible by 8 or not. Next, test of divisibility for 9. If the number should be divisible by 9, means how the number should be. See here, the rule or the principle what you have adopted for 3, the same rule here also you have to adopt, but in the end the resultant sum should be divisible by 9. Okay, for example, I am taking a number 2, 3, 4 and 9. So, 2349 I took. Whether the number is divisible by 9 or not, I don't know. See here, 2 plus 3 plus 4 plus 9. So, which is equal to 2 plus 3, 5 plus 4, 9 plus 9, 18. So, is 18 divisible by 9? Yes. Hence, the given number is divisible by 9. Okay. Next, test of divisibility for 10. So, 10, the unit digit should be 0. Okay. Next, test of divisibility for 11. Let me take an example. See here, 1331. Is 1331 divisible by 11? Yes, definitely it is divisible by 11. So, by applying the principle, let us identify whether it is divisible by 11 or not. See here, one thing you have to do. You have to consider the odd position of the digits or the even position of the digits, but you have to go with from left towards right. Okay, in this direction only you have to consider. Now, I am going to consider the odd position of the digits. The odd position of the digits are 1 and 3. So, 1 plus 3 is equal to 4. So those 1 and 3 you have to add, the resultant is 4. Next I am going to consider the even position of the digits, that is 3 and 1. So you add those two, 3 and 1, which is equal to 4. So the resultant sums you have to subtract, therefore 4 minus 4 is equal to 0. 4 minus 4 is equal to 0. So in the end, if you got a number like 0 or 11 or 22 or 33 or 44 or 121, so a number a number by seeing that if you can decide, then you stop there. Okay, here I got 0, so 0 is divisible by 11, therefore 1331 is divisible by 11. So the ultimate answer after subtracting, what you are going to get? If you get 0 or any number which is divisible by 11, okay, obviously the number what you are going to get is a smaller number. So by seeing that smaller number, you can decide, okay, whether the number is divisible by 11 or not. You can identify. Okay, so here I got 0. 0 is divisible by 11. Therefore, the given number is divisible by 11. Okay, next, test of divisibility for 12. Test of divisibility for 12. See, from here I am going to tell you a trick. You can identify the test of divisibilities for any number. Okay, most of the composite numbers you can identify the test of divisibility. See here, test of divisibility for 12. See, you take any two numbers, if you multiply those two numbers you should get 12 other than 1 and 12. I am taking 6 and 2. Next I am taking 4 and 3. So among these two combination, which number is having HCF between those two, or which pair is having HCF between those two? If you consider 6 and 2, the HCF is 2. But if you consider 4 and 3, the HCF is 1. If you consider any two numbers having HCF 1 between those two, then those two numbers are called as co-primes. Or see, this co-primes concept we have discussed in HCF and LCM. Okay, so 4 and 3 is a co-prime. So for 12, if you consider the co-primes, 4 and 3 are co-primes. So 4 into 3 is equal to 12. So to identify whether the number is divisible by 12 or not, you have to check whether the number is divisible by 4 and 3. If the number is divisible by 4 and 3, then obviously the number is divisible by 12, because 4 into 3, 12, and 4 and 3 are co-primes. Okay, 6 and 2 you cannot take, because 6 and 2 are not co-primes, but 4 and 3 are co-primes. Therefore, if the number is divisible by both 4 and 3, then the number is divisible by 12. If you take 14, see, you can take 14. What are the co-primes? 7 into 2, 14. 7 and 2 are co-primes because HCF is 1 between 7 and 2. Therefore, 7 and 2 are co-primes. Therefore, the number is divisible by 7 and 2. Hence, the number is divisible by 14. Next, you take 15. If you take 15, 5 into 3. If you take 18, 9 into 2. If you take 21, 7 into 3. So you are getting so many co-primes. If the number should be divisible by 21 or not, then you have to check whether the number is divisible by 7 and 3. If it is divisible by both 7 and 3, hence the number is going to be divisible by 21. So this is all about test of divisibility. In the end, I have shown you how to check the test of divisibility for any other number, any composite number. Okay, so for the most of the composite number, you can apply the co-primes concept. Based on the co-primes concept, you can identify the test of divisibility for most of the composite numbers. Okay, most of the composite numbers you can identify. Now, we shall move to the different concept in the number system, that is place value and face value. Okay, see here, I am going to take a number called 1012356. So this is the number I am taking, that is 10,12,356. See here, 6. The place value of 6 is 6 into 1, that is 6 itself. The place value of 6 is 6 into 1, that is 6 itself. That is nothing but 6 into 10 power 0, that is equal to 6 into 1, that is equal to 6. See why we have to take 10 power 0? Because we are solving the problems, or we are considering the values based on 10 system. Okay, base 10 system we are considering. Because of that reason we have to take the powers of 10. Okay, next 5. This can be treated as 5 into 10 power 1. This is 10th place. So the place value of 5 is 5 into 10, which is equal to 50. Next, what is the place value of 3? The place value of 3 is 3 into 10 square, that is equal to 3 into 100, that is equal to 300. 3 into 100, that is equal to 300. Next, what is the place value of 2? That is 2 into 10 cube, that is equal to 2 into 1000, that is equal to 2000. See, can you identify what do you mean by place value? Place value means the value of a number which is decided based on their place. Next, the value of the place value of 1. The place value of 1 is 1 into 10 power 4, that is 1 into 10,000, that is 10,000, that is 10,000. Next, 0. The place value of 0 is how much? 0 into 10 power 5, okay, which is equal to 0. Next, what is the place value of 1? The place value of 1 is 1 into 10 power 6. 1 into 10 power 6. So these are called as place value. If they ask you to identify the place value of a number, see here, I am taking one more number, 2371. What is the place value of 3? 300. What is the place value of 7? 70. What is the place value of 2? 2000. What is the place value of 1? 1 itself. Okay, so place value you have learned. What do you mean by place value? Next concept is face value. Face value. See here, face value means the number itself. Okay, see, the face value of 1, it's 1 only. The face value of 2, it is 2 only. The face value of 7, it's 7 only. The face value of 3, it's 3 only. See here, to identify the face value, the position of the numbers doesn't make too much sense. Okay, it doesn't make any sense. Actually speaking, it doesn't make any sense. Okay, to calculate the face value, the number itself will be the face value. The face value of 10 will be 10. The face value of 8 will be 8. The face value of 3 will be 3. So face value means the number itself. Sometimes they may ask you the question like this. Consider a number, the number called 39,478. Now, they are going to ask you the question, calculate the difference between the place value and face value of 4. Okay, let me repeat again, calculate the difference between the place value and face value of 4. So, what is the place value of 4? Place value of 4, that is 400. Next, face value of 4, face value of 4, that is 4 only, that is 4 only. Now we have to identify the difference, that is 400 minus 4, that is 396, that is 396. So these type of questions they may ask, So now we have learned what do you mean by place value and what do you mean by face value. So next concept is arithmetic progression. The next concept is arithmetic progression. So what do you mean by arithmetic progression? See here, let me take a series. The series is 2, 4, 6, 8, 10, so on till 50 I am going to take. See, can you identify the difference between 4 and 2? That is 2. Can you identify the difference between 6 and 4? That is also 2. Can you identify the difference between 8 and 6? That is also 2. So, between the two successive numbers, if the difference are same, then the series is called AP, that is arithmetic progression, or the series is said to be in arithmetic progression. So 2, 4, 6, 8, the difference between the two successive numbers are 2. Therefore, 2, 4, 6, 8, 10 till 50 is in AP. And the first terminology is called A. Here A is equal to 2. And the difference between the two successive numbers is called as common difference, that is treated as D, that is also 2. Next, how many numbers are there in the series? That is n terms. That is n terms. Okay, next, what is the last number? That is Tn, that is 50. Okay, the last number is called Tn, that is 50. So, you have a formula, that is Tn is equal to A plus n minus 1 into D. To identify the last number in the series, you can go with the formula Tn is equal to A plus n minus 1 into D. And one more thing, to calculate the sum of the values, we can go with the formula Sn is equal to n by 2 into 2A plus n minus 1 into D. Sn is equal to n by 2 into 2A plus n minus 1 into D. So, you can go with this formula to calculate the sum of the given values. So, you have one more formula, that is Sn is equal to n by 2 into A plus L. L means Tn. A plus L. L means Tn. So, you can use this formula also if you know the last value of the series. So, arithmetic progression, why it is called arithmetic progression? When you have a common difference between the two successive terms, then those series are said to be in AP, arithmetic progression. Okay. So, the first term is called A, and the common difference between the two successive terms is called 2, and the total number of terms is called n, and the last number is called Tn, and you can use these formulas to identify the last number. Tn formula you can use, and you can use Sn formula to identify the sum of the values. Okay. So, this is all about the arithmetic progression.